We have a prism ABC of angle A. The angle of prism is A. The ray of light enters in the prism as shown in the way, gets refracted and gets emerged from the prism as shown. At Q and R, we draw two normals. N1 and N2 are the normals at the points Q and R. This I is the angle of incidence. This E is the angle of emergence. This R1 is the angle of refraction in the first phase. And this R2 is the angle of incidence in the second phase. This is the direction of incident ray. This is the original direction of incident ray. That's why we see here delta 1. This delta 1 is the deviation produced in the first phase. Delta 1 is the deviation produced in the first phase. Similarly, the deviation produced in the second phase. Okay, the direction of incident ray for second phase is, the direction is this. And this is the deviation produced in the second case, del 2 in second phase. Okay, if we produce emergent ray in this way, and this delta 2 and this delta 2, they are vertically opposite angle. That's why these two angles are equal. And we show angle of deviation in second phase del 2 here in order to solve the geometry easily instead of here. Okay, this is delta 2 is the deviation produced in the second phase. This is the total deviation. This is the total deviation produced by a prism. Let's see once again. I is the angle of incidence. E is the angle of emergence. R1 is the angle of refraction in the first phase AB. R2 is the angle of incidence in the second phase AC. Delta 1 is the angle of deviation in the first phase AB. Delta 2 is the angle of deviation in the second phase AC. Delta is the total deviation, angle of deviation produced by a prism. Delta is the total deviation. Okay. From geometry, we can easily see delta equals to delta 1 plus delta 2. Okay. What is delta? How much is delta? Okay. Let's see here. How much is delta 1? Sorry. How much is delta 1? Okay. This is angle incident ray, this is refracted ray, and this is emergent ray. And this is the direction of incident ray. Okay, here we draw a normal. Okay, and this is our angle of incidence. This is angle of incidence. Okay, now we want to find this delta 1. This is the, one second, let's see here. Okay, this is the direction of incident ray. This is refracted ray, and this is emergent ray. Let's draw here normal. Okay, this angle is I, and this total angle is also I, vertically opposite angle. And since this is R1, this is equal to R1, this angle becomes I minus R1. That's why this delta 1 is equal to this total angle is I, and this angle is R1. That's why this delta 1 is equal to I minus R1. Similarly, delta 2 equals to E minus R2. Okay, this R1 plus R2 is equal to A. We'll see it later. Just now, we'll see right after this. Okay, from figure, okay, A equals to R1 plus R2. That's why delta equals to I plus E minus A. This is the general formula for deviation produced by a prism. Okay, now let's see how this angle A is equal to R1 plus R2. Okay, this, we have a prism. Let's see this quadrilateral. In this quadrilateral, these two angles, the sum of these two angles is 180 degree. This angle is x. We suppose this angle is x. Now the sum of this A plus x is equal to 180 degree. Okay, A plus x equals to 180 degree. That's why this is equals to 180 degree. That's why angle R O dash and 1 dash. R O dash and 1 dash. This angle. This angle is equal to A. Okay. Now here is the prism. In this problem we see if we draw a graph. Okay, this is delta and this is angle of incidence. If we draw a graph, we see this type. Okay, for each deviation, we see two angle of incidence. For each deviation, there are two angle of incidence. For each deviation, there are two angle of incidence. But for minimum deviation, this is minimum deviation. For minimum deviation, there is only one angle of incidence. For in case of minimum deviation also, actually there are two angle of incidence. But the values of those two angle of incidence are equal in the case of minimum deviation. That's why we say only one value. There is only one angle of incidence when the prism produces minimum deviation. Here question S says, produce a minimum deviation of 51 degree. The prism produces minimum deviation of 51 degree. This is 51 degree. While it produces deviation of 62 degree 48 minutes. The deviation is 62 degree 48 minutes. For each deviation, there must be two angle of incidence, and those two angle of incidence are 40 degree 6 minutes and 82 degree 42 minutes. This is, let's say, 40 degree 6 minutes, and this is, let's say, 82 degree 42 minutes. There are two angle of incidence. Okay, this is prism of angle of prism A. Okay, we saw a ray of light incident on the prism, refracted and got immersed. These two are the normals. Okay, this is angle of incidence, this is angle of emergence, and this is the deviation produced. Now we are going to learn for one deviation there are two angle of incidence. We are going to learn how there are two angle of incidence for one deviation delta. Okay, in this case, the deviation produced is delta equals to I1 plus I2 minus A. This is I1, I2 minus A. We just saw it. Now, let's apply principle of reversibility. Now, what we are going to do, in the first case, the angle which was angle of emergence, this is angle of incidence in the second case. The angle which was angle of incidence in the first case is angle of emergence in the second case. But in these two cases, if the value of deviation here is x degree, then the value of deviation in this case also will be x degree. Okay. In this case also, delta equals to I plus E minus A, I1 plus I2 minus A. Thus, there are two angle of incidence. This is one angle of incidence, and this is one angle of incidence. But the value of deviation, these two angle of incidence are same. That's why there are two angle of incidence for one deviation. Okay, now let's solve the problem. Okay, this is angle of deviation in first case, angle of incidence in first case, angle of emergence in first case. This is angle of incidence in second case. This is angle of emergence in second case. This is angle of deviation in second case. Now, the deviation produced by a prism is very simple. Delta equals to I plus E minus A, I equals to I1 and E equals to I2 minus A. Now, let's substitute the value. Delta equals to 62 degree 48 minute, and we change minute. 6 minute equals to 6 by 60 degree. When we divide minute by 60, it goes to degree. Now we found angle of prism is 60 degree. The angle of prism is 60 degree. The minimum deviation is 51 degree. According to question, the minimum deviation is 51 degree. Now delta minimum equals to I plus E minus A. In case when the prism produces minimum deviation, I equals to E. That's why I plus I minus A. That's why delta minimum equals to 2I minus A. Okay, let's substitute the value. We got angle of incidence as 55.5 degree. Now let's use formula. We get refractive index of glass with respect to air is 1.65. Okay, this is 45 degree and the refractive index is given 1.5 and the value of critical angle is C equals to sine inverse 1 by 1.5. We get the value of critical angle is 41.8 degree. C is 41.8 degree, but I is 45 degree. What we see, I is greater than critical angle. That's why this suffers total internal reflection from this face. Okay, now this angle is also 45 degree. That's why the deviation produced is 90 degree in this case. Okay, this is the problem. Okay, this is the direction of incident ray and this is the direction of reflected ray, the ray reflected from the mirror. This angle is delta. This is 1.5. This is 90 degree. This is 88.5 degree. This is also 88.5 degree. This is 1.5 degree. This angle is 178.5 degree. The deviation produced by a prism P is we have a small angle prism. That's why we can apply the formula for a small angle prism delta equals to a mu minus 1, which is equal to 1.5 degree.